Hello, scientific people. Here in this video, we are going to do these 1, 2, 3, 4, 5 questions from the chapter Light, Reflection and Refraction for class 10th. Well, this diagram over here is for this question. So altogether, we are going to do these 5 questions, and all questions that I have taken here are mainly from a reflection. That is, they are questions based on mirror and not lenses. So let's begin with the first question. The next question says a student determines the focal length of a device X by focusing the image of a far off object on the screen. Well, this is what the screen position, as you can see in the figure, the device X. So what is this device X here? Now we have these options given over here. So first of all, we can see from here that a reflection is taking place, right? One thing is clear, that there is a reflection taking place. So reflection can take place only in case of a mirror. So we can discard these two. A and B cannot be the answer. Now, next we can see over here the rays of light coming from here actually getting converged at a point. You can see they are converging at a point. So converging can be done only by a converging mirror. And what is converging mirror? That's concave mirror is called the converging mirror. So we'll say that option D is correct in this case. So device X has to be what? The device X has to be a concave mirror. Now, in the next question, it says, why does a ray of light passing through the center of curvature? So it is the case of center of curvature of a concave mirror after reflection is reflected back on the same path. So we are talking about the concave mirror. Now, after reflection, so if I take the diagram for concave mirror, right? So let's say this is the case, I suppose. Yeah. So this is the case. What you can observe, the rays of light which is made to pass through the center of curvature, right? After reflection, it rebounds back on the same path, right? It is rebounding back on the same path. So this is because the line joining the center of curvature, the line joining the center of curvature to the point of incidence is actually act as a normal. Now you may be wondering, how can this be perpendicular? This is because of the curve path. In this case, well, we don't have to study in detail. This act as a normal, right? This is acting as a normal. And you know that whenever a ray of light, whenever a ray of light passes through the normal, normal is what? Anything which is perpendicular to the surface of the surface. Any polished surface is called normal over here, rebounds back on the same path, right? So the answer for this will be, that is because the incident ray falls on the mirror along the normal of the reflecting surface. So as I suggested, as I told you that here, this act as the normal, right? This is acting as a normal, right? And to the surface of the mirror, to the surface of the mirror. And that's why we say it should pass along it will rebound back on the same path, or you may say that it retraces its path. And the next question, it says, what is the difference between the virtual images produced by a concave, plane, and convex mirror? So we have to find a difference, right? And here the difference is only in case of a virtual, right? Not all cases produced by number one, concave, plane, and convex mirror. So I can begin with a plane mirror. Let's say if I write the characteristics, right? In case of a plane mirror, the image formed will be what? It is virtual, erect, and equal in size, right? Now, the next case is what? For let's say if I take concave mirror. In case of a concave mirror, what do you observe? We are just talking about the virtual image, right? So in case of a virtual, not all cases, as I said, it is virtual, erect, and enlarged. And finally, the case of a, what's that? Convex mirror. So, so this is a case of a convex mirror. So in case of a convex mirror, the image formed is going to be virtual, erect, and diminished, right? So it has to be virtual, erect, and diminished. So one more time, if we are just looking into the virtual difference, right? Here we are looking for the difference only in case of a virtual image, right? Only in case of a virtual image produced by concave, by plane, and by convex. So in case of a plane mirror, it's virtual and equal in size. In case of a concave, if it is virtual, right, then it is enlarged. And in case of a convex mirror, if it is always virtual, but at the same time it is diminished. The next question says that state two possible position in which a concave mirror produces a magnified image of a given object, and we also have to tell the two difference between the image in these two cases. Now, first of all, we need to figure out that two positions we have to find out in case of a concave mirror when the image is magnified. So magnified is what? Enlarged. So we can see this is what a case of an enlarged. And the other enlarged case is this. So what you can see that two cases when number one, when the object is between C and F, and other is between P and F, that is between pole and the focus. So if I just make a rough sketch of a concave mirror, like let's say this be the backside of the mirror. So and let's say this is focus and this being the center of curvature. So case one, let's say if I talk about this case, the image formed is real inverted when the object is placed between C and F. So you can see that here the rays of light after striking the mirror will pass through the center of curvature. Sorry, it will pass through the focus, and the other which is made to pass through the focus after reflection will meet here. So you can see this time the image formed is enlarged. That is, this is bigger, right? This is the object in this case. Now, this is what the first case, and the second case when the object is between F and O, sorry, F and P. Say if I keep the object instead of here, I can keep the object at between F and O. So if I keep the object over here, what you can see that the image formed here is virtual, erect, and enlarged. So the rays of light coming from here after reflection will pass through the focus. The other rays of light, which is made to pass through the focus. So you can see on producing these, they meet behind the mirror, and the image formed in this case will be what? Virtual, erect, and enlarged. So we got these two cases, and the two cases you have to write. Number one, when the object is between C and F, and between other cases between F and P, that is principal focus and the pole. So we get this to enlarged image. But then we have an extended part. We also have to tell the difference between the two images. So the difference is this, that in case of first, that is, in case when the object is between C and F, it is real inverted, and in the other case, it is virtual erect. One more time. So when the object is between C and F, the image formed is real inverted, and when it is between P and F, that is pole and focus, it is virtual and erect. The question says that no matter how far you stand from a mirror, irrespective of your position, your image appears erect, and the mirror is likely to be, we have these options as the plane mirror, concave, convex, either plane or convex. Now, let's begin with the plane mirror. So what we know about a plane mirror, that in case of a plane mirror, the image formed is what? Always virtual, always erect, and always equal in size, right? That's what we know about a plane mirror. Now, let's consider the other also, like this you can see, this is a table for a concave mirror. Now, here you can see that for different position of the object, right, we have image as real inverted, can be diminished, highly diminished, same size, real inverted, enlarged, could be equal in size. And in only one case, it is virtual erect. But then our question is, no matter how where you stands. So you can say that it cannot be. One thing is clear, that it cannot be concave mirror. Now, if I check for the convex mirror, you can see that Irrespective of the position of the object, the image is always virtual and always erect. So we get to know that plane is one such correct and convex. But then we have an option that is either plane or convex. So in that case, we should say the correct option is plane mirror.